So good morning, everyone, and thank you for joining HashiCorp and Cisco for today's webinar. My name is Karen Wee. I'm Senior Partner Marketing Manager at HashiCorp, and I'll be helping to facilitate today's webinar, titled, very interestingly, No More Node, the Mother of All Networks, Redefining the Intelligent Network with Cisco ACI and HashiCorp Consul. During this session, we will explore how Cisco ACI, HashiCorp Consul, and Consul Terraform Sync can work together to provide end-to-end application discovery, network visibility, and infrastructure orchestration. Please feel free to type your questions during the webinar using the Q&A feature. This webinar will be recorded, and the recording will be available after post-processing, which usually takes a few days. Now I have the pleasure to introduce our speakers, Nathan Pierce, Consul Specialist with HashiCorp, and Nick Ramondo, Technical Marketing Engineer with Cisco. We'll finish with a demo and a Q&A session. And now here's Nick, who will start the presentation. Thank you, Nick.
Thank you, Karen. Hi, everyone. So welcome to this session. What we will be talking about for the next 45 minutes is really about networking and application, how they relate together. But most importantly, the foundation for this conversation is really about the degree of awareness a network should have in relation to what's happening at the application layer, and also in terms of the services that are running on top of that network. And to talk about this, we're going to follow this quick agenda. So I'm going to start by introducing why Consul and ACI, what we are trying to solve as issue with this type of integration. Then we'll follow up with Nathan, who is going to introduce Consul and different solutions such as network infrastructure automation. Then I'm going to show you a quick demo around the Consul Terraform Sync and how we can automate ACI together with Consul, and also about the visibility aspect in terms of what's happening in the network and how you can also monitor the application and make relation between the network and the application itself. And then we follow up with question and answer. So let's get started. So we're going to start with this more, I would say, controversial statement, which is really about, does a network need to be intelligent? Which most of the time people will say, no, it doesn't, right? Because it's just a pipe. But when I'm talking about the network here, you can really see it as the network of all networks, the holistic approach to network, because you may have network islands here and there. For example, if you're running a software overlay for a specific solution, or if you connect it to a cloud, you may have like a edge connectivity to it. And at some point, those networks need to be all connected together, right? It has a lot of legs. It's thought to resemble an ugly beast, right? Because it connects many, many things together, running a lot of different protocols, but it doesn't know what is connected to, right? It doesn't know about the application and what is running there. And if you think about it, the real function of the network, it's true, it's just to make the application work, right? Because the network itself doesn't bring money or doesn't bring benefit to any organization. It's the service you run on top of that. But at the same time, to be able to make the network always on, you need some sort of awareness of what is running. Because if you need to handle changes, let's say, for example, I want a new port deployed there because my application is scaling, or I need to deploy an application, or maybe there is an issue on one of my port, but you won't be able to know what is the application that is impacted by that issue. And how do you know if you need to scale, if you need to add new port? There is no real relation in terms of what will be sitting behind that. So to be able to solve this kind of issue where you can put more context into what you are going to deploy in the network, and also in terms of being able to correlate a particular flow to an application, and also being able to orchestrate that, you need a good foundation. And this is why we have built ACI from day one. you need a intelligent API being able to drive any component of that network. And ACI, this is exactly what it is. It is a single centralized API that is basically converting a collection of individual switches into a single network. ACI is really a model-driven network, which means that you don't directly talk to your end switches, right? You don't talk to your spine. There's no notion of that. You only talk to your centralized API that may also be, that is front-ended, of course, by our controller UI. Even our command line, for example, is also using the API itself, right? So the API is really the center of ACI, that is basically providing another, you can really consider ACI as another tier in your application, right? In the same way, microservices, architecture will call out maybe your backend service. Here you call your backend network service. And the way it is done within ACI is that every object in the network, so for example, a VLAN or our EPG, which is the equivalent of a security group, all of that is represented as objects that are configurable via the API, right? And also things like health information, counters, all of that are also represented as objects inside the APIs, which makes it a good fit for any automation tools and also any programming language, especially object-oriented programming language, because ACI has this notion of class, attributes, etc. Right? So it's very easy to map this out to programming language. Okay, so now that we have stated, just the foundation for a modern network, what does it need to do? Because as I said, to be able to maintain an application or application lifecycle, you need some sort of visibility in the network. That's one, to be able to correlate application to flows. And second one is automation. You need to be able to react to application changes and demands so that the network gets provisioned, right? But it's not only about that. It's also about security, right? So what we see from our customers is that the zero trust model is really mandatory. So typically it operates at L2 or L3, and the function of that is essentially by default, everything is closed, and then you open the channel, you open the pipe when it is required, right? And with the right protocols. So that's one, right? But in itself, the security requirement should not come from the network itself, right? It's the application that is determining what kind of security is required in the network. And then the role of the network is to open or close those pipes. Then verbosity, right? The network should be able to provide a hop by hop insight and correlation between the flows, so between what's happening inside it, between the protocol that is used, and the application that is mapped to it, right? Another very important part is being able to detect anomalies, like what is deviating from your normal patterns, all those kind of things. Even if it's not necessarily self-healing, you should be able to have at least an alert telling you, look, this is not normal. We can see some deviation from the standard behavior. That's something that is really important. Also, when I mentioned that zero trust, it has to be adaptive. The security and policies should be in the right place. So whether you have an app running with Consul, or whether you may have a Kubernetes integration or other requirements, it should be easy to modify the network accordingly. And finally, which is also very important, everything you drive through policies should not be IP-based, right? Here again, I'm talking about the holistic approach. Of course, when you configure the platform, the foundation of the network, of course, you will have policy based on network components. But when you start deploying workloads and some payloads onto that network, anything you do in terms of connectivity policies, securities, should really come from this higher level, higher source, which is the application layer. So as a consequence, it doesn't make sense in modern data centers or for modern application to talk about IPs, because nowadays with things like Kubernetes and containers, anywhere those IPs are ephemeral. So it's really important to talk about service and to basically decouple those network notion IP MAC from the service that is really running on top. And last but not least, the foundation to enable this is infrastructure as code. But more importantly, as I was mentioning before, all this automation requires you to get not only the code in Git, for example, but it also needs the data, and the data you need to ingest as an input for this automation is really key. So we are moving into, especially when you talk about infrastructure, it's not necessarily infrastructure as code, because the code is there, it's the automation. What is really changing is the data. You can apply the same set of workloads every time, or workflow every time, but the inputs will be different. Now the real question is, how do you get that input? Right? This is what I call infrastructure as data, and we're going to see. Obviously, this is what we are going to solve with Consul and ACI together. So not only is the automation important, so I've mentioned the couple of benefits that you will have by integrating Consul with ACI. Is faster end-to-end deployment, moving away from strict network requirements and strict application requirements on two different stages. Everything is merged into one stage, which starts at the highest level of truth, which is the application that will be then ingested into the network as inputs, right? So this is where the data I've mentioned is coming from. It should come from there. And with Consul, because Consul is by default dynamic and always updated with what the application that is running, of course we have direct access to all that data, right? It also allows you to get self-healing infrastructure, because as soon as a service dies or changes, you can take action about it, right? Which ultimately lead to less frictions between the developer persona or the app owner personas, as well as the networking and, more generally speaking, the infrastructure personas. And the second stage, I would say, benefits is really about visibility, because now that you have all this automation, you need to be able to say, look, okay, now I've done action on that particular network segment, on that network part of the infrastructure, but what is the service running in terms of data operations? Is it up and running? Is it down, and why is it down? Is it because the service has failed, or is it because of another reason? So this correlation becomes even more important when it comes to data operations and maintaining this network as well as the application lifecycle. So basically, it will allow us to have a reduced troubleshooting time to resolution, and this is through the ACI Consul service app that I'm going to show you also in the demo. It allows us to have service visibility inside the network, basically correlating IP address, MAC address, all the strict network vocabulary and objects into instance level, or like service level, which is really important. Okay, so with that said, I'm going to hand it over to Nathan, who is going to talk to you about Consul in more detail.
Fantastic, thank you, Mick. I appreciate that. You definitely had cooler slides from me. I recognize the alien from The Simpsons, Zorg, I think his name was. I'll do my best to try and match that awesomeness. So, yeah, I'm Nathan Pierce from HashiCorp. I spent 20 years of my career in infrastructure networking, so I understand the pains, and Nick did a fantastic job there of just explaining the pressures that are coming on network operations and infrastructure operations that we have to address. I work at HashiCorp. I'm a Consul specialist, so I'll talk a little bit about kind of what Consul is, its primary use cases, but also what drove the market need for something like Consul, this very different approach to service-based networking, and then how we're doing lots of great work with companies, particularly Cisco, to help our joint customers to leverage some of this automation workflows for the greater good. So I'll jump right in. Console at a very high level is these three use cases. So we typically talk about service registry and health monitoring. What's going on in a intentionally ephemeral, volatile environment. So the whole breakdown of the monolith into microservices has created enormous opportunities to accelerate time to value. How can I get that revenue generating, productivity improving service to market, but then not have to do all the manual infrastructure, cloud platform work around getting it visible, available, secured, etc. So this dynamic service registry and health monitoring of everything going on in a chaotic microservice environment is one of the more popular use cases in Console. It takes care of all of that. Where is everything? What's available? What's healthy? And how do I get it? Second use case, zero trust networking. So Consul's approach to networking is very much a point-to-point, mutually authenticated, encrypted, service-oriented networking. So a deny all and then defining service-based intentions, certificates used at each end to identify each service, and that is all dynamically managed by Console. Console's unique difference there is its multi-platform service mesh. You typically hear the term service mesh associated with something like Kubernetes, what I refer to as a mono-platform service mesh. Console's entire focus has been across all of the platforms, bare metal, virtual machine, microservice, Kubernetes-based services. Its focus is around the availability, the discovery, and interconnectivity of everything. And then the last one, and it's last only because I need to set up what Console is all about before I get to the integration, and that is the network infrastructure automation. So if you haven't heard of Console, that is absolutely fine. It is actually extremely widely deployed. We've got numerous customers running services that we all use every day and running them at huge scale. So Console's actually been around, I think about 6 years. It was one of the earliest products made available by HashiCorp, and it's definitely keeping a lot of the internet and services we love up and running. So let's move on, just a little detail of some of these use cases. Service discovery and health monitoring, and here's a bit of a glimpse of what it looks like. You register a service when a service is deployed, and each service has nodes that are capable of delivering that functionality. So not having to manually do these things, manually set up DNS, manually set up VLANing, subnets, etc., etc. Turns out people really love that. The network infrastructure automation, we're going to touch on that in a minute, because there's infrastructure around the application that needs to receive updates and be informed of changes. That's what this whole NIA strategy is for Console, reducing time to market, and then this zero trust. I'll touch on that a little bit and kind of how that works as well. At a very high level, architecturally, what does Console look like? We deploy it with a 3-node cluster. You can add more servers to the cluster for increased scale. We have people running 25,000 plus nodes against a single 3-node cluster. And then we deploy a Console client agent with the application. So Console's the control plane that understands where everything is and communicates that back to the cluster, which is running a consensus algorithm, ensuring that we always have up to the microsecond visibility of everything running in an environment. So it's a small binary that is deployed with an application. Pretty common practice in the app and kind of microservice automated deployment world. These agents communicate with each other and with the service, so they're always aware down to the micro-7 level. They're calculating network coordinates, so whenever service A needs to find service B, we can get you to the absolute best serving node that should respond to that. I can definitely recommend, if you want to go deep into how all that works, on the console.io website, look at the architectural internals. It goes into very advanced things like CAP theorem and trade-offs between availability and performance, etc. We are very public and open about our approach to those things. So really cool documentation there on how all this land loss protocol works. But in a nutshell, a set of servers, and then the clients are all communicating with each other and reporting their state to those servers, and that is how the service discovery engine works. It's a database of what's available and where it's available, and it's agents performing the requests of where can I get something and how do I get it. So why do people need something like Consul? Why do we have all of this ephemeral kind of intentionally introduced chaos going on and microservice architecture? So first, I just want to reset on kind of DevOps itself. I'm a DevOps purist, so I don't look at it as like a role or a team. It's an operational approach. It's around reducing operational friction. And the objective here is getting these services, productivity improving or revenue generating services, to their service consumers, the intended audience, as fast as possible. That is the goal here. How quick can we bring value to market, time to value? Now, DevOps drove a lot of innovation in the continuous integration, resulting in accelerated continuous delivery. So continuous integration, the developer checks in some code, that code runs through automated testing. The result of that automated testing, if all goes well, is the generation of an output. That could be a binary or a container or some kind of artifact that is then ready for deployment. However, the reality is that innovation, which has been huge, if you want to see how big that ecosystem is, definitely search for DevOps periodic table of tools. It is enormous. The reality being, though, for most enterprises, when you go into production to deploy, that is still quite manual for most people. And that is because it's been very CLI and GUI driven. I mean, we're not just talking networking, we're talking security, we're talking server infrastructure, etc. A lot of that is still very much manually administered by people, and people can't keep up with the pace at which microservice ephemeral architectures are being developed, deployed, and constantly changing. Now, this shone a big spotlight on the network and kind of security, the infrastructure world, and a lot of fantastic work got done around automation of these fields. However, much of it was often still disconnected from the deployment of the application, this higher order source of truth of value, like how do we interconnect these two worlds? So there's still this manual handoff and this continuous disappointment, that I refer to it, the third CD in CI/CD for the app owners who are just trying to get their value out there into the market. Now, Consul is fantastically positioned for bridging this gap, and this is why we have fabulous relationships with our partners, especially Cisco. And you'll see some awesome examples of that a little later from Nick. So, jumping along a little deeper into some of these use cases, I think everyone's pretty familiar with the problem around kind of service discovery, because the way we used to do it was in spreadsheets. There are still people using spreadsheets. I even saw someone write a REST-based macro in an Excel spreadsheet that talked to infrastructure to update the IP addresses. Now, I know that sounds a little reverse, it's a bit backwards, bringing their infrastructure back into a spreadsheet with automation. It was still really cool to see, but not very useful. They still had to manually do deployments. So it's trying to get away from these archaic methods of kind of running things. And then obviously the ideal goal is just being able to query an API or DNS queries and asking the local agent via a loopback adapter, hey, I need to get the service feed, where is it? And it telling you, not just randomizing, but it actually saying this one is this many microseconds away, I'm going to give you it because that's going to give you the best kind of service. So making that a transparent experience for people. So service discovery is fantastic. I talked a little about it, so I think I'll skip this a little. The zero trust networking. I mean, how do we get an ephemeral architecture environment of microservices out into production without having a flat, insecure network? It's extremely difficult unless you've got something like Consul that has this visibility of everything that's going on and the policies of service A can get to B, so it can create those MTLS point-to-point connections between the two, and allowing us to have a flat network, but a zero-trusted, deny-all flat network that ensures only the right things can get to the intended destinations. And a quick glance at sort of what that looks like with this sidecar proxy concept. Consul has its own built-in proxy, but we also work with third-party proxies like Envoy, for example, very popular in microservice environments. Where Consul does all the configuration, certificate management, and ACLs, so that you never have to touch all of this infrastructure. Consul just needs to be told, you know, what services are allowed to get where, and how should that work. at a service-based level. No one ever needs to interfere with any of the IP level. That is all dynamically managed by the agents and their land gossip. So now, the network infrastructure automation, why? Well, we just talked a little bit about the problem that DevOps brought, that manual handoff between these ephemeral microservice environments and then the infrastructure that's there to deliver and present that value to the world. Now, we saw when that spotlight shone on the industry, like this is how things were when DevOps and that whole CI/CD pipeline grew rapidly and people started deploying. We still had in front of them this ticket-based approach, this manual approach, which happens to be very error-prone. My first meeting this morning was with a customer who a person typed the wrong IP address into their load balancer and deployed some test code which totally broke their loyalty program and cost an enormous amount of money. That's all it takes, mistyping an IP address. It was in the right pool. The problem was everything in their environment was tagged test and production. And in an automated solution, it would have known only to put the production ones into the production load balancer pool. But of course, because people were involved in that manual handoff, that is where those errors occur. And just picking up the wrong IP address, picking up the test tagged node instead of the production node was all it took to cause them a lot of chaos and a lot of problems. So that still happens on a daily basis. And why? I mean, just look at this process. I'm going to click through it. We don't need to read it all, but I mean, just pressing these buttons kind of hurts a little to see. But this is often, I mean, we like to beat up on ITIL, but I think it's, ITIL's not the problem, it's the implementation. It's the fact that it's click this button, type this command, versus why don't we create an ITIL compliant workflow that's reproducible without human intervention in every change. I think that's the future of ITIL. Have a reproducible pattern, but not a human intercepting pattern at any point. So we can get away from all of those things by using network infrastructure automation and HashiCorp's Consul Terraform Sync. So with all of the automation push that DevOps brought into infrastructure, we saw a lot of response from the market of and from the media of just saying, oh, we'll just teach everyone in networking and security how to write Python code and bash scripts, which I think helps many organizations. But if you haven't got a great team of expertise of that type of scripting that also has a great understanding of the impact of the code they're writing and the way that they're hitting APIs, you can very quickly be creating an enormous amount of technical debt. And I mean, yeah, there are great scripters and automators out there. I mean, there are huge organizations that have the staff to pull it off, but the vast majority don't have that inside of their networking and security centers of expertise. So how do we bridge that gap without the expectation that in 6 months we make everybody who's been using a CLI into a programmer that we trust in a production workload 100% of the time? So HashiCorp responded by filling that gap between Consul and our network provider partners with Consul Terraform Sync. Now, the short version on Consul Terraform Sync and how that works and what it looks like, Consul already sees every change that's coming. You spin up an agent and it's aware, it's registering that with its database. So it's in the perfect place to be an event trigger. It's always witnessing the changes when I go from having 3 nodes that are advertising themselves as able to respond to anything for service1.xyz.com, and then suddenly I spin a 4th one up. Well, that change is witnessed immediately in microseconds to Consul. So why not use that event to then go and instruct and inform the network? Now, the APIs have always been there, and historically, our partners have polled Consul asking, has anything changed? Has anything changed? Has anything changed? If anyone's got kids and been on a long car journey, they'll be familiar with the polling model. Are we there yet? Are we there yet? That's effectively what was happening in the past. Now, though, we're using Consul as the source of truth, and when it sees a change, instead of polling, when it sees a change, it goes out and informs the network infrastructure. Now, the most effective and efficient way of doing that was to use an already industry-trusted tool, Terraform. So Consul Terraform Sync, think of that as the conduit between Consul's constantly up-to-date database of what is where and what's changing, and Terraform as its huge library of providers. If you go to registry.terraform.io, you will see there are an enormous amount of providers in there. So we have that conduit between console and how to best talk to those solutions. And many of those Terraform providers are actually written by the organizations themselves. Cisco is maintaining its provider, so you know it's reliable and trusted as a source of communication. So for those who aren't familiar with Terraform, it is basically the de facto kind of cloud deployment infrastructure as code provider. Like it allows you to templatize your infrastructure. You can repay data centers with it, which is fabulous in a reliable kind of getting back to the last known good state. A quick glimpse under the hood of kind of how it works. You define a driver. Here I am specifying a driver for ACI inside my console Terraform sync. So this is a binary console Terraform sync. When I create, when I install it, I tell it where console is. It introduces itself to console saying, I am a node, not like the normal service nodes. I'm a node that will kick off workflows for you. It registers its destination. That's that Cisco DevNet ACI. So this is a driver it can use. Then after that, we create tasks. Now this is the critical bit to how all of this works. When we create this task, we're telling it what provider to use. We have ACI registered in there. We tell it, though, more importantly, what services should I be telling that Terraform provider about? So in this case, I am registering with console anytime a change is made with the infrastructure that is serving the tag services API or web. I need you to grab all of the information about that, its IP address at that exact point in time, and all of its metadata, its tagging, and I need you to pass that to the Cisco ACI driver. I can also then add some user-defined variables that might need to be passed. It could be an access key, username or password, that type of thing, whatever that provider might need to do its job, complementary to just knowing about what the services are. But it is this simple. We are now just telling console, anytime you see something with these tags, if you see a change to that, I need you to go and inform this driver, and it will do whatever it's been defined to do in a very reproducible, maintainable fashion. So I hope that was useful to you. If you have any questions, do the Q&A now. I will start looking at the Q&A, or save them to the end. I've got a few things I can share there, and I'll share some links to documentations in the chat as well. But at that point, I'm now going to hand back to Nick if he's ready.
I am.
Yeah, the professional. Oh, you did the slide for me and everything. Fantastic. Yeah. Thanks very much.
Hey, no worries. So can you hear me? Because yeah, okay, I've unmuted myself, so I just wanted to be sure. Thank you, Nathan. So hopefully by now, you should have an idea of what I meant by, the difference between infrastructure as code and infrastructure as data. Infrastructure as code, a lot of tools can do it. Of course, Terraform is one of them, probably one of the most popular. But for data operation, as Nathan mentioned, we need more than that. Ingesting data manually as input for the automation is not necessarily a smart way to do it. That can lead to a lot of mistakes. And as also Nathan mentioned around DevOps principle, what I want to touch on just before going to the demo is the current patterns of automation. If you look at the cloud native worlds and Kubernetes, OpenShift, all those kind of very edgy type of environment, the new way of doing automation is essentially to do a perpetual feedback loop, right? Where essentially you have to reconcile the state of your infrastructure with what you want to configure. So DevOps taught us two things. One, put everything on Git, right? It's a lot easier to collaborate. It's a lot easier to track changes and share. And second is the way we do automation has to change. It's also true from the infrastructure point of view, because if what you put on the network, right, or any parts of the infrastructure is adapting new patterns, then you should adapt to it. And this is exactly what we can map out to the Consul Terraform Silk and the network infrastructure automation aspect. So if you think about it in terms of the operator model in Kubernetes, or the GitOps model, if you like, you have the pipeline, or you have your CI pipeline, which is sort of conditional orchestration. In the case of Consul, well, the pipeline is essentially you monitor a service, you have a service change, and you trigger a workflow, a Terraform workflow based on that. You need infrastructure artifact to be able to configure your environment according to the changes that needs to be put. In our case, the configuration templates would be the Terraform plan. In the case of Kubernetes, you can use customize or any sort of templating solution to deploy into your environment. It needs to be event-driven. In that case, so as Nathan said, Consul is monitoring what's happening for the application itself, and then we feed Terraform. And this continuous watch will be the Consul Terraform sync daemon that will be running in your environment. That will watch the state of the Consul services, and then will tell Terraform, oh, I've watched this change. Can you trigger Terraform apply, or can you do Terraform destroy, etc., etc. So it's really like the equivalent of a webhook, and this is just the pull kind of model which Nathan talked about. And finally, of course, like in the operator framework in Kubernetes, we need some sort of custom controller, and the custom controller itself, it is the Consul Terraform sync binary, right? So the point is here, I wanted to make you aware that if you just look more closely to it, it's exactly the same principle as what the cloud native kind of environment is doing, the platform is doing, things like the operator framework. So I think moving forward, it's a common pattern across all the data center segments, application or infrastructure. Okay, so now I'm going to do a demo. So we have a couple of, so we probably about 10 minutes for the demo, should be fine. Where I want you to show two things essentially. First, the automation bit. And the first module we have for network infrastructure automation and Consul Terraform thing, it is based on scaling, let's say, web frontend, for example, or actually any tier you want to scale. The idea is that one. So in ACI, we have a function that is called ACI policy-based redirection that allows you to create a VIP in your fabric and tell ACI, okay, behind this VIP, I have this IP/MAC address, right? So essentially, when you add more backend services, or when you scale your tier, then you add more VMs, or it can be virtual server, it can be containers, it can be anything. I mean, this is the beauty of ACI; it's compatible with any form factor. Then, traditionally in ACI, you have to do that manually. You have to create what we call a redirection policy, so that the VIP can redirect to one of those servers. So it's a stateless load balancer in hardware. So the idea is to create a very fast redirection, so that when the user on the left, that is depicted here, wants to access the service, it hits the fabric, and the fabric will just take the decision based on the hash. Okay, I'm going to forward you this to that particular backend, or that backend, or that backend. Right, so it's a very simple load balancer, stateless, L4, very fast, because ACI, of course, can be 100 gig fabric, so it's pretty fast. And the idea with Consul Terraform thing is that now, instead of doing this manually, we will tell Consul, please, Consul, if you see that there is a change in terms of those backend services, so Consul will run on those backend services and monitor that. If there is a change happening, like if a service dies, or if I'm adding a new VM that will pop up with the service, with the Consul service configured, then please scale up or scale down my VIP to include those backend services dynamically. Right. So, and how it works, as Nathan mentioned, is it's using Terraform plan in the backend. So it's using a Terraform module that you can access from the Terraform register. And then the second thing I want to show you is, oops, as a result, is in the same way we have this automation integration with Consul, we also have a visibility app that we recently developed, that will allow you to do all this correlation I've mentioned before between all the endpoints that are residing into the ACI fabric, so MAC address, IP address, BD, PG, all the traditional ACI construct, as well as the underlying services that are mapped to those endpoints. So now I'm going to switch to the demo. Karen, if you can just push my screen. Is it okay? If just someone can tell me if you see my screen, that would be great. Yes, okay, thank you for that. So here is the current configuration. So I'm currently logged into my one of my VM where I have my Consul Terraform thing binary. So as I said, it's just a daemon that you can run on any station, right? So it's going to be acting as this perpetual, controller that's going to watch what is coming from Consul, using it as a data source. So it just required a couple of configurations. The main one is really the config.htl that Nathan mentioned before. So in our case, it's just required, I've got one Consul server, which is that IP address. Listening on port 8500, which is a classic port for Consul. I'm going to be using my Terraform provider, which is ACI, right? And I'm going to just put it the provider configuration. So I just give it a credential to connect to my APIC, which is my controller, my network controller. I just give it like how I'm going to connect to it. So I'm going to use, in that case, a certificate-based authentication. Then I'm going to tell what service I want to monitor. And finally, the task. So the task is really one-to-one mapping to a module you need to run. So in our case, the service I want to monitor and to act upon is called frontend. It's going to be using my ACI provider. And I'm going to give the source. So the source of the Terraform modules, right? And the last thing it has to take as a parameter is the input for that particular Terraform module. Now, in terms of the input, it's very easy. Oops. The input here, I'm just giving it the tenant name in ACI, as well as a prefix I want to use for my policy-based redirection. So I'm just going to trigger my Terraform sync binary. So now you're going to, it's going to be watching now. Everything that's going to happen in Consul now will be monitored, and the Terraform workflow, the Terraform plan will be triggered every time a change is detected by the CTS. Right. So if I look at my ACI fabric now, oops, I'm disconnected. So the tenant in which I want to manage this automation is my Consul tenant. So the current module that we have provided is just acting upon the host-based, the redirection policy. The service graph, the PDR, the policy-based redirection should be already deployed, right? So, but as I said, CTS is really based on modules. So the next module we are going to deploy is really focused toward that use case, where we're going to also create service graph templates and deploy them. But currently, the first module, it will be acting on this policy, which is the policy-based redirect. So what I'm expecting here is that as a new service pops up on the network, I should create a new policy here, adding the relevant backend services, and my service graph that I have pre-provisioned manually currently will be using that policy to redirect the traffic, so that, let's say, my user coming, who wants to access that particular application will hit the fabric, and we'll hit a rule that will say, okay, if you want to reach that VIP that is created by ACI, then you will be redirected towards one of those backend services. So let's take a look at those services that are not running at the moment. I want to monitor them. Right? So I've got 3 VM where I've got console configured, very simple console configuration where I'm just specifying my console server, and the service configuration itself, my front end, is very easy. I'll just have Nginx listening on port 80, and as a check, I'll do it very cheaply. I'm just using curl. It's just to show you later on the app integration app for visibility, how it's displayed. But it's very simple configuration. So I've got the same thing within every VM, which I've got 3 of them that will act as a backend service for my front-end application, right? So here I'm going to start my system CTL, start my Nginx service. Here I'm going to do the same thing for the other one, and now I should see a reaction in CTS. So CTS is detecting those changes, and if you watch closely, you will see that it's going to trigger the different Terraform plans. So now you've seen I have three change, and let's take a look at the ACI environment now. So you can see that I've got a new policy-based redirect that has been created. And now you can see that I've got the IP address of and the MAC address of my different application backends that are composing that particular redirection policy. So now every time, every time I'm going to hit my VIP, I'm going to be redirected towards one of those 3 backend services. So now what's happened, let's say if one service died, right? That's the question. So let's take a look. Let's again system CTL stop my Nginx. Okay, so now you see again Terraform will trigger a destroy, and in ACI automatically I should see another. You can see that automatically it's saying that the backend service is not healthy. As a consequence, I'm removing it from the potential destination, right? And again, if all my services die, you would expect, oops, this one and this one. I should go into the similar situation where the infrastructure is updated. Here, let's wait for the end. Okay, to destroy. And I'm back into my first situation where there I don't have any policy anymore. So if your rule hits, if the traffic hits this particular rule, actually it's a non-valid rule, right? So it will be a black hole essentially, right? The service is down, the whole service is down. So let me put everything back up, because now I want to show you the second part, which is the visibility aspect. So here we have covered the automation, and I want to cover the visibility, and for that I need my service up and running. So if you see on the console UI, you see by default, right, you have all the information. We don't do anything magic here, right? Magic here. We have all the network information in ACI, and we have all the application information in console, right? You have your front end that are defined there, and you can see the all the service, health check, these kind of things. But now the real value of the integration app is in a single place. If I'm a network engineer, how can I correlate my endpoint information in ACI and this information there, right? So this is what I'm going to show you now by using the console app integration. So it's an app you can download from App Center. So Cisco ACI App Center. It's working on a per tenant basis. So you will find the console app on the right corner here. And the first thing you're going to notice is you have a dashboard here that's going to tell you what is currently deployed, the number of service check passed, the node check, the endpoints that are connected. And so non-service endpoints mean where you don't have console installed, because we are not expecting people to use console for every single workload in the data center, right? So you have the repartition here. So the way you integrate this, you just connect to your console server, which we call the seed agent, and from this you will discover the console topology. So now if I go into operation, you will see your, let me just make the screen a bit smaller because, like this should be easier to view. You see my current environment. So I've got my console server and I've got the three nodes that I've used for this demo. So let's take, for example, the first one. You're going to start now seeing on the right all the information that is related to that. So you can see a mix of ACI and console information. So here you have the endpoint, MAC, IP, learning resource. So you see that it's coming from a VMware environment. You have the vCenter IP address, the vCenter name, you have the interface that is leading towards that VM, you have the VLAN encapsulation, but then also on top of that, remember, like I was using curl to just check that the service was healthy. Look, you also have this now. So you have direct access to all the application level information. So this is what I mean by having deeper visibility of inside the application stack. So you can notice not only if you have an issue with the fabric, with the ACI fabric, if you notice that you have an issue on that particular, so it's not a VPC, but it's a port, on that particular port, by default, you know that this service will be impacted, right? And you will see the consequence of that. Also, you can have another view that will give you a more organizational fashion of managing this. So you can manage the view at your endpoint level, like what I did, but you can also select your whole application. Right? So you see the same view, but it's just depicted differently on a per application basis, where you will see all the event analytics, configure policies, contract where required, and also a console summary with the node check, which is about the surf status. And again, as before, all the individual services check, right? So I think this is really important. This kind of application is really key to operate modern data center because it's really linked. It provides the missing piece between the application and the infrastructure, right?
Nick, if I could just join in and highlight something that I think was really amazing, what you just showed. I think largely a lot of the trust of this reduced operational friction being pushed by DevOps initiatives and continuous integration, largely the friction against kind of adopting those paths was the people not focusing on the importance of visibility. Like, I'm suddenly told to trust this higher order source of truth, but how do I know what to do with it when I'm the one that gets the phone call being told, well, it's your network, work it out. And I think what we just demonstrated, like, I love the Consul Terraform sync. You definitely solved the problem I mentioned earlier, my morning call with a customer who accidentally lost a lot of money by putting the wrong IP address in. You definitely solved that with the Consul Terraform sync integration, but I love this second part of your demonstration here, that it just demystifies what's going on. You've taken away the need to manually be entering things, which is wrought with opportunity to fail, but also made it highly visible, but not operationally expensive to get that visibility.
Yes, exactly. And also the important thing here is remember that you have access to all the faults here in ACI. So here I don't have it. Yeah, I've got a couple of them, but not like super important ones. But that's
no faults. Yeah.
Yeah. So, but the point is, it's like one step away, right? So you have the application view there, and you can directly deduce, okay, I've got a fault. Is it related to my port of my low-level network configuration? And you can see now also the impact that it has. Right?
Yeah, and that is sorry, the time to market we talked about before, the speed of getting that value the developers created that has been signed off, past testing, and is being tagged as a service for production is now immediate.
Yes, exactly. And also it's so I wanted to show you today also like the Kubernetes integration. So it's not properly like completely working, but I've configured part of it. And so the point here is that if you use the, the seed agent is coming from Consul Connect. So we are not limited by the form factor, which means that now if you use the ACI CNI, which basically make container first-class citizen in the network, right? You also have access to the same type of information. So it's not necessarily reduced to VMs or bare metal. We also, if you use the ACI CNI, you have the same visibility that is provided by both the Consul Connect part and our CNI, which really made the container first-class citizen also in the ACI platform. And so, yeah, I think for the last slide, I think a couple of minutes now for question, but I've got just the last slide I wanted to push, which is just the key takeaways for today. So let me push this, it should be there. Back to this. So, yeah, the key takeaways for today is hopefully we've been able to show you that ACI Consul used together kind of unlock really unmatched capabilities for modern networks. Also, I want to insist that SDN alone, whether it's ACI or any other solution, is not enough to support modern application lifecycle, especially when it comes to data operation and when you need infrastructure as data. The real question is, how do you handle this data? Is it manual, where you risk potential risk or basic mistake, as Nathan mentioned, for his customer, or do you want to use a higher source of truth, such as Consul that will give you all the information about the application? And Consul effectively provides updated information on application and will give you all this infrastructure requirement from that higher level of source of truth, acting as a source of data, feeding this into Terraform. And because ACI has a Terraform provider, then we can also take action on that. And last but not least, with the visibility integration application, you can also act for this data operation when you have an issue. Should it be an application issue or a network issue, you will be able to be aware of all the pieces of the puzzle, right? And of course, with Consul and ACI, we make the network, basically we make ACI more application centric. A couple of other resources if you're interested. We have some Terraform labs if you want to practice a little bit with the Terraform provider for ACI. HashiCorp has tremendous amounts of learning tutorials on their website, which is really well done for Consul, especially talking about Consul service mesh with Consul connecting Kubernetes or traditional Consul. You also have here the modules we've created for what I've shown today, so the PBR information. I've also linked the network infrastructure automation program documentation, the architecture, all the weeds of that, and finally the link to the Consul ACI extension app if you're interested in that. And we have a couple of, we have, I guess, is there any question? Maybe we can take one or two.
Yes, Nick, I think one question came in. What modules are available for ACI and network infrastructure automation?
Yeah, okay, so in terms of the module, as I've demonstrated, this is the very first module that we have created. And moving forward in the next upcoming weeks, we're going to create other modules to also facilitate that use case, but not only about the policy-based redirection, but also allowing you to create the policy-based redirection graph, the service graph, creating the VIP, etc., etc. Today, you will have to do this manually, the automatic piece being the redirection policy. But yeah, moving forward in the next coming weeks, you will have other modules for that use case. And in the future, we also want to focus on more security-based use cases, things like maybe micro-segmentation or being able to trust particular workload and automatically embed, kind of configure the security for them in the cloud.
There's one more question, Nick, if you have time.
Yeah.
So the question is, do you need to install Terraform for the CDS with ACI?
Yeah, actually, no, it's parts, and that's the beauty of the thing, I think, is the CTS binary is just what you need. It's going to take care of all the Terraform binary, the Terraform plan generation. It will create like subfolder with all the information, so you don't have to install anything but the small binary actually. Yeah.
And just to add to that, Consul Terraform sync is storing its state in the Consul database, and we will also be adding support for storing the state in Consul, the cloud-based platform that we have. So, sorry, Terraform, the cloud. So you don't have to worry about now building a highly available workflow path between Consul and ACI, because we can repave that and use the state that was preserved. So the state's not stored locally on the virtual machine or the container or whatever you use to run Consul Terraform sync. It looks after itself.
Cool. Awesome. One more
Thank you,
question.
Nathan. Thank you to the audience. I think we've run out of time. I hope everyone enjoyed today's webinar and has a better understanding of how Cisco, ACI, HashiCorp Consul, and Consul Terraform Sync can work together to provide end-to-end application discovery, network visibility, and infrastructure orchestration. There's a short code at the end of this webinar, which we hope you can complete. And finally, as mentioned at the beginning of the webinar, this has been recorded and we'll make the recording available after processing. I'll send an email to everyone who registered with the recording link. Have a great day. Goodbye.